So we have to evaluate this integral. Believe it or not, you can evaluate this integral in 1 second if you understand a few things. For instance, we understand that we have to evaluate this integrand from a negative pi to pi, which is a symmetrical interval. And so we understand, for example, that for an say I have a symmetrical interval from a to a of f of x dx. I should get 0 if f of x is odd, right? However, we notice that this is a product of two functions, namely sine of 3x, which is this is an odd function. However, this one is even. So what happens when you multiply an even function with an odd function? So odd times even actually gives you odd. And hence we got an odd function over a symmetrical interval. And so the actual answer here should be 0. That's how you evaluate this in less than 2 seconds. Now I could get you through the intuition as to why this is the case. So I'm just going to take as an example, I'm going to take a function sine theta. So this will be negative pi, and this will be pi. So this is f of x is equal to sine theta. Sine x, excuse me, that should be sine x. So we notice that if we eventually, essentially what integration is just you're just summing a bunch of areas. So you're summing the area under a curve from this interval to the area under a curve from this interval. And so we find that if we were to add these two areas, so this will be a negative area, this will be a positive area, and they're equal in magnitude, but they're opposite in sign, and so the sum of them, the algebraic sum of these two areas should be 0, and that's why for an odd function it should be 0 from if the interval is symmetrical about 0, the point 0, and that's it.